To make sure that this recorded correctly, I wanted to just go over it one more time with you and add the oral 21 just to make sure that it was in the previous video. This is that methodology I was referring to that I find to be easy in some cases, depending upon the numbers. And I'm going to show you a nice, easy, clean example, and then I'm going to show you a messy, ugly example of how it can be a little bit tricky. So it kind of depends on if you're focused and aware whether or not you might make a mistake. Okay, these are the three items that we want to find the greatest common factor and the least common multiple on. Look at these three items and find out what they all share. The largest, if possible, because if you find out the largest thing that they all share, then you pull it out and then you're pretty much left with the greatest common factor. But whatever you see right off the bat is okay as well. 5xy is what I noticed that all three of these shared. And when I pulled this divisor out of these three dividends, here were the quotients that were created. Looking at these three items one more time, I noticed that they no longer share anything. That being the case, this is what they shared, therefore that's the greatest common factor. All of the factors multiplied together is the least common multiple. Now, something to be aware of, on page 180, we are reminded that even though I have a negative number in my list, my least common multiple cannot be negative, okay? That's because no matter what I multiply this by in terms of multiples, 15 times 1, 15 times 2, I won't come up with a negative number. Now, I realize that I could multiply this by a negative number, but multiples in and of themselves are positive. Therefore, the least common multiple must be positive. So the least common multiple is a product of all of these getting rid of the negative. And there's your answer there. This one was nice and clean and easy, but I do have another one for you that's not quite as clean. And I'm going to go ahead and get it started. Okay, so I've created another alternative one for us to try, and it looks super easy. Factoring this by primes would probably be an easy way of doing this, but I want to show you that this other method is also possible. All three of these seem to share 2y. Pulling out 2y here results in 4x squared. Into that, I'm left with 6y. And into that, I am left with 15x. Okay? I am left with 15x. Now, nothing else is shared by all three. Therefore, that is the greatest common factor of that list. That being said, the least common multiple is what is divisible by maybe two of them. Okay? So we can compare these two items. We can even compare these two items because I can pull out my x squared, my x out of that. So what do? Well, pick whatever two seem easiest to you. I'm going to start with these two right here, just because they're on the left. I'm going to pull a 2 out, and that gives me 2x squared, because this is what was shared. Don't let that confuse you. This is the only thing that was shared. We're working on least common multiple now. That leaves that. That leaves a 3y. Now, we did nothing with this guy, right? We did absolutely nothing with him. So I am just going to pull him down to the next level, just so that I don't forget that I am still looking at this list to figure out my least common multiple. It looks to me like this can be solved by pulling out a 3 here. A 3 out of these two, not out of this one. I should have just not drawn that over there. But I'm going to bring this down because this one is not actually in this party. But the 3 is going to come out of those two. 3 comes out of that one, which leaves me a y. 3 comes out of that one, which leaves me a 5x. Okay? I brought the 2x down because I couldn't divide it, just like I brought the 15 down. Okay, now I'm left with x's that can be pulled out. X leaves me with 2x X cannot come out of that one, so I'm just going to bring it down, and 5. Okay, so if you have more dividing to do after you've identified your greatest common factor, if you have 2 of them that are divisible, you can simply bring down the ones that don't fit in that scenario, or you can just draw the boxes in a way that kind of eliminates that from the party. In any case, what I am left with at this point is the least common multiple. 2 times 2 is 4, times 2 is 8, 8 times 5 is 40, 40 times 3 is 120. That's my numeric coefficient. X, x squared. Y squared. Now, a lot of you might say, I don't even want to include the variables in this because I can see the largest power is x squared of the x's and y squared of the y's. That's totally fine. You could have eliminated that from here and simply included it as part of the least common multiple. It's just another way of thinking about how these numbers all work together, okay? Again, though, you could see how this can get a little sticky if you don't recognize that you still have to divide the remaining terms if a pair of them share anything. In this case, we had to do a lot of flipping and flopping because we had these guys sharing numbers, these guys sharing numbers, and these guys sharing letters, but not all 3 sharing anything after that point. Okay? So I am going to leave you with that. Use whichever method